Graphing linear functions, one of my favorite things to do. So, what's interesting about this lesson is after we learn what linear functions and linear equations are, that's pretty much going to be the focus of this entire unit. And then when you guys get into algebra next year, it's going to be the focus for the whole first part of algebra before you get into nonlinear functions. So this is really crucial. It's really foundational. There's no other way around it. You got to get this. So here's your I can statement. I can identify a linear function and graph it. That's all you got to do here. By the way, I hope this video isn't too long, but there's a lot here. So if you were ever going to take notes, this is a good one to take notes. If you were ever going to pay attention, this is a really good one to pay attention on. Okay, a linear function is a function whose graph is a non-vertical straight line. So in other words, for something to be a linear function, this word linear implies a common rate of change, which when graphed looks like a line. Okay, and we're going to talk about that later. But it can't be a vertical line. It can be a horizontal line, it can be a line at an angle, just not a vertical line. And then a linear equation is an equation that represents a linear function. And these equations always look like this. So this y equals mx plus b, that's really the rest of the unit. We're going to be dissecting all of this and figuring out what each letter does to the line. But just to give you an idea, you guys have already in the last lesson graphed equations like this. This isn't the exact equation, but I know you graphed things like 2x plus 1. So all this is a way of showing equations like this using letters. So in this case, m is 2, x is x, y is y, and b is 1. So you already are somewhat familiar with these kinds of equations, and we're just taking it to the next level now. Okay, so remember that I can statement. You need to be able to graph them, and you've already graphed them in the last lesson. You just come up with those input-output tables, those x, y coordinates, and put them on the chart. But then I want you to be able to tell if something is linear. And there are two ways to do it. The first way is to analyze the equation to see if the equation matches this form. Because if it doesn't look like mx plus b, then it's not a straight line. Or it's not linear if it doesn't have that form. The second way you can tell if something is linear, if an equation is linear, is to graph that relationship or that equation and see if it's a non-vertical straight line. And if it is, you'll know. So I'm going to take you through two quick examples, and I'm going to try and go through both of these methods. First, let's analyze an equation given a problem. So this problem, it's kind of hard to read this up here. I apologize for that. It says experts recommend that adult dogs have a daily intake of 50 calories per kilogram of the dog's weight, plus 100 calories. Write an equation that gives the recommended number of daily calories y for a dog that weighs x kilograms. Then show that the equation is a linear equation. Okay, this writing the equation part, I'm going to do that for you today. You're not going to have to do that until the next video, in the next lesson. But for now, I'm just going to do it. Okay, so if we wanted to know the total amount of calories for a dog, it said that the dog would need 50 calories per kilogram of weight, and they want us to represent the weight as an x. So I'm going to put an x here to represent weight. And I know it's got to be 50 per kilogram, so I'm going to have to multiply that by 50. So whatever kilogram amount the dog weighs, remember a kilogram measures mass or the weight of the dog, we have to multiply that by 50. But then it says plus 100, so I got to put a plus 100 here. So we have this equation, y equals 50x plus 100. And the first thing we can do to tell if this is linear is to see if it fits this form. Does it fit the form y equals mx plus b? And in fact it does. We have the y, we have the equal sign, we have m is 50 being multiplied by x, and then b is 100 here. Something to point out to you, the only two values in an equation in this form that should be numbers and not letters are m and b. Okay? So we have 50 and y. Everything else is letters here, variables. So here's the second way. That first way here was analyzing the equation to see if it matched the form. If it matches the form, you're good to go. If it doesn't match the form, then you're not good to go. One thing I do want to point out is it is possible to have a b of 0 where there would be nothing here. It would just be y equals mx plus nothing because b is 0, and it's still linear. So keep your eyes out for that. Okay, so in this particular case, we can complete a table given this equation that we created, y equals 50x plus 100. And when we create the table, and I've already done the calculations, we should see points that we can graph. So if we plug 6 in for x, 6 times 50 is 300 plus 100 is 400. 8 in for x would be 50 times 8, which is 400, plus 100 is 500. So y would be 500 in this case. And 600 for 10, because 10 times 50 would be 500, plus 100 is 600. 700 for 12, and 800 for 14. I don't want to have to take you through all those, but just notice I plugged in these numbers for x, and it gave me these y values. I just did the math, okay? So now I've got a set of points that I can graph. Okay, let's see. I've got 6, 400. So it looks like we're counting in twos here on the bottom part of this scale and weight. So here's 6, and here's 400. I'm going to make a point. I have 8 and 500, 12 and 600. Wait a second. Did I do something wrong here? I've skipped 10. That's what it is. Sorry. 10 and 600, 12 and 700, and 14 and 800. It's kind of hard for me to see this for some reason. Okay. Now we look at these points that we plotted and we ask ourselves, do they all fall on a straight line? And of course, you know, the answer is yes. And I'm not very good at drawing straight lines, so forgive me. But this would continue. This graph would continue up and extend forever in both directions, and it is a straight line. So using this method, we know that it must be a linear function. We graphed the relationship and saw that it was a non-vertical straight line. Quick reminder of what a vertical line looks like. A vertical line would be something that goes straight up and down like this. If that's what your graph looks like, then it's not a linear function or a linear equation. But since ours doesn't look like that and it is a straight line, we know it is a function. So there were two methods. We analyzed the equation, which is really the fastest method, and then we just graphed it to see. And you're going to have to do both methods on your worksheet. But now I want to look at something that's not a linear function, use both methods on that, and then we're done. So first thing I'm going to do is I'm going to analyze this equation. Okay, and here's the equation that I wanted us to try. Y equals x squared. The question is, does that fall into the format of y equals mx plus b? Well, I know that there could be a plus b here if b equaled 0, because then there would be nothing there. So it kind of satisfies this part of the equation, but does it satisfy the mx? It has the y part and the equal sign, but does it have the mx part? Well, if m was 1, then I guess you could put a 1 here and it wouldn't change anything. But there's one part about this that doesn't work, and that's the square. See, this x right here, I'm going to rewrite the equation so we can see it better. This is crucial. If you're not listening intently, listen now. This mx, this x has a little exponent of 1 here. Remember, any number to the first power is just that number. So if you change the exponent to 2, it changes the equation totally. Let me show you how this looks if we graph it. And I'm just going to set up a quick table and erase what I've done here and graph it real fast. So I've analyzed the equation, and I noticed that it fit a lot of parts, or a lot of the y equals mx plus b, but it didn't fit the most important part, which was the power, which is very crucial. And so therefore it's not linear. But let's graph it to see if it's a non-vertical straight line. If it is a non-vertical straight line, then I made a mistake and it is linear. But let's see if it is. The way that I graph these lines, guys, is I create a quick table. I'm kind of lazy, so I make my table in kind of a shortcut method. And I just draw kind of a line here and here. And I showed you this before. I put my x here. And I start picking some x values. Now I'm going to pick -2, 0, +2. I'm going to also pick -3 and +3. And the reason I'm picking these values is I kind of know what this graph looks like, and so I want to show it to you. So we plug in these values for x. What's negative 2 times negative 2? We would plug negative 2 in for x here, and it would be negative 2 squared. Oh, that would be a positive 4, right? And so we continue on down the line here, getting our points. 0 would be 0, 2 would be 4, negative 3 times negative 3 is 9, and 3 times 3 is 9. When we graph these points, we get 0, 0 for this. Oh, I'm sorry, I should have done negative 2, 4 first. So negative 2, 4, 0, 0, 2, 4, negative 3, 9, and 3, 9. And actually, it makes this beautiful, and I'm going to not draw it very well, but it makes this beautiful parabola, we call it, that goes on like this. But it is not a straight line. In fact, I knew that it was going to be hard for me to show you exactly what this looked like because I'm not very good with my pen. So I went to my favorite graphing tool online, and I graphed it for you. And I just want you to see this graph, how beautiful this curve is. It makes a beautiful curve. But notice what happens here when I change the equation on the left. If I get rid of that 2, and I just come in here, and I change it to like 2x, see if it will work. Oh, for some reason that one's not working because I can't seem to get rid of the little exponent part. So I'll type in a new one. 2x, it makes a perfect line. What was the difference here? Well, if I change this to 2x squared, anytime you have an x squared, you get this parabola. But look what happens if I get rid of this, this coefficient of 2 here on the side, it just makes the parabola wider. Same thing down here. If I get rid of this 2, it just makes the slope different. It makes it the angle of the line different with respect to the x-axis. So you can see the difference between y equals x, which is blue here, and y equals x squared, which is a parabola, which is red there. And the difference is quite significant. So we can tell now of a surety, for sure, that this is not linear because not only does its equation not fit the y equals mx plus b form, it doesn't graph a non-vertical straight line. So in your assignment today, you're going to have to work hard. You're going to have to stretch your brain, but there's some real-world application problems. You're going to have to graph and see if they're linear. And then I just will give you some equations and say, are they linear? And if I just give you an equation, you are more than welcome just to try the method of seeing if it fits the form y equals mx plus b. But if I ask you to graph something, I want you to see if it's a non-vertical straight line. Like I said, this lesson is probably one of the most important lessons of the year. So give it your best shot. I know you're going to do great.